Hi everyone! So right now we are going to talk about measures of skewness for today's topic, and this is still under the data management. So let us start, of course, with the definition of a measures of a skew or measures of skewness. Skew is a measure of symmetry in the distribution of scores. So what do we mean by that? Of course, we need to illustrate the distribution and let us know what are those three types of shapes of distribution. First, we have the symmetrical distribution. This is also known as a bell-shaped distribution. Why it has been called as bell-shaped distribution? Because it is similar to the image of a bell. So the symmetrical distribution, when the skewness is close to zero and the mean is almost the same as the median, distribution shows that mean is equal to median and equal to mode. So all the values are at most at the center of the distribution. And let's see now the positively skewed distribution or the positive skew. When the right tail of the histogram of the distribution is longer and the majority of the observations are concentrated on the left tail, in this case we can use also the term right skewed or right tailed. And the median is less than the mean, or mean is greater than median and greater than mode. So let's move forward to the third type of shape of distribution. We have the negatively skewed distribution or the so-called negative skew. When the left tail of the histogram of the distribution is longer than the majority of the observations, it is concentrated on the right tail. So in this case, we can use also the term left skewed or left-tailed distribution, and the median is greater than the mean, right? Mode is the highest value, which means mode is greater than median and greater than the mean. So how can we be able to determine the shape of the distribution? We have five methods here. First is the measure of central tendency. Next is via the histogram. Third is using the stem and a leaf plot. Fourth is by using the box and whisker diagram. Fifth is by using the Pearson's coefficient of skewness. So let us take now one of the examples for using the measure of central tendency values for getting the shape of the distribution. So we have three different cases here. Um, if the mean is the highest value on the data, it means that it is skewed to the right. But when the mean is the lowest value, the data is skewed to the left. And if the value of the mean, the median, and the mode are equal, the data is normal, or it is so-called like a normal distribution. Okay, aside from saying that it is a symmetrical distribution, we can say it as well a normal distribution. So let us take a look at the example. Say we have here, okay, say we have here the mean, which is 74.5, median is 71.5, and mode is 70.5. So we can infer that mean is greater than median and greater than mode. So in conclusion, the shape of the distribution is skewed to the right, or the so-called positively skewed distribution. Let's take a look now at the histogram. So when we use a histogram, we are using this to identify the shape of the distribution as well. And first we need to draw the line like this. Okay, then identify the line if it is skewed to the right, skewed to the left, or symmetry, or a normal distribution. So based in our example, the line is skewed to the right. Therefore, the distribution is known as positively skewed. Okay, so let's see now the stem and leaf plot method. So let's take this example. Of course, the simple method of organizing quantitative data first is we need to arrange the data into ascending order. So we will use this example here. So we have this right now. The given data, I arrange it already in ascending order. And how can we able to plot it in a stem and leaf plot? So stem is used to prove the score, for example, ones, tens, hundreds, and meanwhile the leaf shows the individual values within each group. Next, the most important information that you must remember is that the leaf is usually the last digit. So based on the example, leaf is somewhat like 6, 1, 8, 5, 4, 3, and 0. So first step, arrange the data in ascending order as I mentioned, and then next step, write down the stem. So here we are using the class interval of tens. We have 20 to 29, we have 30 to 39, we have 40 to 49, and last is 50 to 59. Right? So next we need to write down the leaf. Any observation or data, then we need to use or to write down in every row in ascending order. Okay, so one step at a time. So what I mean is one row at a time, and make sure that it is in ascending order. So first, let us take a look at this 20s from 22 to 25. So we are gonna write down this 20. So we have the leaf of 2, 2, 4, 5. As you can see, we have 22, 22, 24, and 25. And next is the 30s. So write down those last digits. So we have 31, 30, 31, 33, 36, and 38. Let's move forward now with our 40s. We have 40, 43, 44. The last one we have 50s. So we have 50 and 53, just like this. We have 5 here and 0 here and 3 here. Means we have 50 and 53, like that. Alright, so as you can see here, let us take a look and draw a line again based on the distribution of the lines. Based on the distribution, say we have. So when we draw a line here, we can be able to determine what kind of distribution is it, or what is the shape of the distribution. So we can conclude that distribution is skewed to the right or positively skewed. Okay, so let's move forward now to the next method for finding the shape of the distribution. We have box and whisker flat method. Let's take this example. So of course we need to arrange the data again from the smallest to the highest value. So arrange the data. Next, find the smallest value. So we have 5. And next will be the first quartile. So from our formula for finding the first quartile, we have n plus 1 divided by 4. It means our quartile is in the 6th position. So that means it is the 12. And median will be 15. I'm sorry, this should be 1. Okay, 15. Next is for our third quartile. We can use the 3 times n plus 1 divided by 4 formula. So it means that our third quartile is at the 18th position. So it is 19 here. 19. And then the largest value is 29. This one. Okay. Alright. So next step that we need to do to create a box and whisker plot, we need to create or draw a horizontal line like we are plotting the x values in a certain Cartesian plane. So we need to put the following: 5 for our smallest value, and then here in this part is our first quartile, which is equals to 12, and in this part, which is the median, is 15, and then we have 19 as our third quartile, and then we have 29 as our largest value. So after that, draw a box between the first quartile, median, and the third quartile. Right? So we have the box here now, and draw a whisker on the left side and the right side from the box of the whisker flats. And the distribution is skewed too. How can we do it? How can we be able to understand or infer what will be the shape of the distribution? Let's take a look. What is the longest line? Right? As you can see, the long line is on the right side of the distribution. It means that our data is skewed to the right, or it means that it is positively skewed. Okay, this one. So next is the using the Carl Pearson's coefficient of skewness. This is the fifth method for determining what is the shape of the distribution. We have the formula mean minus mode divided by the standard deviation. In case mode is indeterminate, we can use 3 times the quantity mean minus median divided by the standard deviation. So this is the formula for finding standard deviation, and yeah, this is the symbol for standard deviation. And as you can remember in our last topic, the standard deviation is the square root of variance, because this formula inside is the formula for finding variance. We just put square root to get the standard deviation. Okay, so let's move forward to the interpretation. If the s cube can be also denoted as the measures of skew. Okay, this is also sometimes the formula, the denotion, or how you can be able to represent the measures of a skew aside from sk underscore p, right? We can also use that. So if the computed value for the measures of skew is less than 0, then the distribution has a negative skew. And then if the computed value has greater than 0, then the distribution has a positive skew. But what if we get equal to 0? It means that the distribution is symmetrical, or a normal distribution, or what we call the bell-shaped distribution. So the more different to the values of a measure of skew is from 0, the greater the skew in the distribution. So let's take a look and apply those formulas. Suppose we have the following distribution of number of students enrolled in Bachelor of Surgery at University of Oxford. Determine the skewness of the data. So we have 12, 13, 54, 56, and 25. Alright, so first, of course, we need to get the value of the mean, which is 32. We add this, all the values, and then divide it by 5. So we are just going to create a table to make sure that our answer is organized. So here on the first column we have the data, all right, and we get the summation of s, which is 160, or the equal is 160. And on the second column, get the difference between the data and also in the mean. So we have 12 minus 32 is negative 20, 13 minus 32 is negative 19, 54 minus 32 is positive 22, 56 minus 32 is positive 24, 25 minus 32 is negative 7, and then you have an idea as well, because you already computed for that standard deviation on our last topic. So when you're getting the difference between the values, or each of the values as well as the mean, and when you get the summation of it, you're going to get a 0. So if you get 0, it means that you got the right values on each. Alright, So we're just going to square this computed values that we have. We have 20 squared is 400, 19 squared is 361, 22 squared is 484, 24 squared is 576, and 7 squared is 49. So get the total again. So we have the summation is equals to 1870. Alright, so we already computed for the value of the summation. X minus the mean squared is equals to 1870, and n is 5. So we need to substitute the computed values, and then we are going to solve for it. So we have the square root of 1870 divided by 5 is square root of 374. Then solve for it, substitute it to our given formula, which is the 3 times the quantity mean minus median over the standard deviation. So our mean is 32, and when you go back to our distribution, you can get the median value is 25. So we have 3 times the quantity 32 minus 25 all over square root of 374. So 3 times 32 minus 25 is 7, and 3 times 7 is 21. So we need to divide it by the square root of 374. We'll get 1.09. So it means that our s cube, alright, s cube or the sk sub p is greater than 0. The computed value for measures of skew is greater than 0. Therefore, the distribution has a positive skew, or skew to the right. Next, we have if mean is 60, median is 75, variance is 900. As you can see, we have the value of variance here. And clue is for getting the standard deviation, you're just going to get the square root of the variance. So the square root of 900 is 30, then solve for it again. So we have 3 times mean minus median over the standard deviation. So we have 3 times 60 minus 75. The given, just substitute and divide it by 30, the computed value for the standard deviation. So we have 3 times negative 15, and 3 times negative 15 is negative 45, divided by 30 is negative 1.5. So our computed value for measures of skew, the s cube or the sk sub p is less than 0. Therefore, the distribution has a negative skew. Alright, so that will be all for today, and thank you so much. God bless you all.